Welcome back to Way of the Wrench, and on today's very special episode, I have a very easy introductory video on how to get going with shielded metal arc welding, otherwise known as stick welding. So come along, you belong. So the first logical question is, what is stick welding? Well, stick welding is an electric welding process where we use electricity to create enough heat to melt the base metal, as well as melt and deposit our consumable electrode. Now, to protect that molten puddle from getting any porosity, we have a flux coating on here that will cover the weld and make a little gas cloud of inert gas that will keep the oxygen and atmosphere gases out of the way. And it shields the puddle, so that's why the shielded metal arc welding. Now, these consumable electrodes, when they pop in and out of these holders, they look like sticks, hence the nickname stick welding. Woohoo! Look at that. That there be a nice looking weld, methinks. So far in the How to Become a Welder series, we've learned about gas welding, MIG welding, and TIG welding, and now we're on to stick. So what's the benefits of using stick? Why would I choose stick rather than the other ones that I already know how to use? Well, stick welding's got its very own pros and cons, so let's talk about that. So some of the reasons why you might want to use a stick welder over some of the other welding processes is, number one off the bat for me, is that if I've got a thick plate steel project I want to make, and it has to be really, really strong and have a lot of good penetration, it's going to be stick welding every single time. And because of that, that's why it's used a lot in heavy duty equipment repair and construction of bridges and buildings and tanks, farm equipment and pipeline, stuff like that. Now, because we've got these consumable electrodes burning off and giving off their own inert gas, that also means we don't have to rent or buy bottles. We don't have to buy the inert gas. We also aren't concerned too much about working outside and having that inert gas being blown away by wind or rain, because that inert gas is burning and being created right where we need it. Now, the other thing that I really like about stick welding is it is not as picky about what the surface or your prep of the metal is like. So if it's got a little bit of rust or some paint or even some dirt or mud, just give it a wipe, and chances are you're going to have a really good weld when you're done. Now, the other thing that I really like about stick welding is that, let's say I'm welding steel today and tomorrow I want to weld cast iron and the next minute I want to weld aluminum. All you got to do is change out your electrodes in your holder, as opposed to maybe changing out a whole 50-pound spool in a MIG welding machine, which is going to take you some time. Now, as for downsides for stick welding, almost every single pro I just told you about has an equal and opposite con related to it. So for example, I just finished telling you that stick welding would be my go-to for any kind of thick plate steel projects. That also means that if I've got thinner metals or sheet metals to weld up, I'm not really going to be going to the stick welder. Can it be done? Yes, it's just a little bit harder. The ability to change these electrodes out depending on what job I'm doing or what position I need to weld in, that's awesome. However, these consumable electrodes also are going to get used up pretty quickly actually, and so you're constantly changing these electrodes out, which slows down the process. Now, the ability to create its own inert gas is amazing. However, it also creates a slag that covers over our weld beads that we manually have to chip off with a chipping hammer and clean with a wire brush every single time we stop welding before we start again. Now, the last thing I'd probably add to stick welding disadvantages is that it is a dirtier, smokier process. So if you're doing this inside your home garage, you might want to think about that. And the metal tends to splash a bit, which makes spatter, which requires you to clean up after as well. Now, before we do any kind of welding process, it's really important that we understand the safety aspects so that we can keep ourselves safe and keep the people safe around us. Now, in the interest of keeping these videos short, I've made a really great electric welding safety video that I highly recommend you watch. I'll put the link above for you. Now, in this video though, I do want to cover a couple things that are very specific to safety for stick welding, so let me show you those. All right, with any of the electric welding processes, we're going to want to have safety glasses underneath our helmets, and it's especially important for stick welding. Reason why is when you are done your weld, everyone does the same thing. you lift up your helmet and you get your eyes in there and take a look at how you just did. However, stick welding has that slag coating over the weld bead that is now cooling and shrinking, and it likes to pop. And you can get sometimes these things coming up about a foot, foot and a half, and if you got no glasses on, you're going to get it in the eye. Now, the other thing too is immediately after that, you're going to be taking a chipping hammer and you're going to be smashing that slag off, and you're going to be wire brushing, so really high potential of having something hot stick up into your eyes. Now, when you're stick welding, you're going to want to have some welding gloves on, and we were previously using these nice thin deerskin gloves when we were TIG welding. They will technically work. However, remember, stick welding is a lot more heat, a lot more spatter, so really a nice thicker cowhide welding glove with a nice big gauntlet is going to do you a lot better, protect you, and last a lot longer. Now, the one thing that's different about stick welding as opposed to the other electric welding processes is there is no button on the torch or a pedal that initiates the start of the welding. As soon as you turn on the machine, this welding electrode is live, and so if you put it down on the table to readjust your work, you're going to get a flash and flash your eyes and have some potential for injury. A safer route is to shut the machine off before you put it down. And while we're on this topic, the end of this welding electrode is going to get crazy hot. So do not start getting into the habit of putting this over your leg and kind of resting it that way. If this goes and touches your coveralls and your jeans and your underwear, you're going to end up with a nice little burn mark down there. So put it elsewhere, shut the machine off. All right, once you've watched that electric welding safety video and you have all your personal protection equipment on and you know that everyone else is safe around you and your work area is safe, it's time to start talking about setting this thing up. So let me show you that. Okay, on this welder, we have the option of using TIG or stick. So we've got a mode button here that we use to select it. So we don't want it on TIG, so we're going to switch it to stick. Now the cable coming from the machine that says work, you're going to follow that cable down until you find a ground clamp, and you're going to put that right directly to your metal table that you're going to weld on, or you can mount it directly to the piece that you're welding on. Okay, and then the cable that's got your electrode holder, on the other end of that cable is going to be this end. It's got a little bump in it, and that goes into this keyhole shape where it's marked as electrode. Line it up, put it all the way in, and then turn it right just by hand till it's nice and snug. Now, when it comes to setting your polarity, ultimately it depends on what electrode you're using, and based off the flux coating that's on them, that will tell you what polarity you're allowed to use. Now, when it comes down to you can have any of these to select from, the next thing, DC electrode positive, is probably going to be used 90% of the time, because this is the one that is giving the high heat, high penetration. So you're going to be using this for your nice thick plate steel projects. Now, when you go to DC electrode negative, this is going to give you less heat, less penetration. So this might be a better choice for thinner metals. And then when you go to AC, this is maybe used on certain types of metals like aluminum, where it might weld better, and magnetized steels. So sometimes you're working on something that's been rubbing in the dirt for years and years and it's become magnetized, and AC is a little bit resistant to having the arc wander or go away from where you want it to weld because it's been magnetized. But like I said, 90% of the time you're going to be on DC electrode positive. Now, in order to adjust the heat input in your stick welder, we are now adjusting amperage, not voltage, and we need to have a good number to start with so that we're not too far off, and we can always adjust it from there once we get going. Now, when you're starting off, it's a little tricky to figure out what this number should be, so I recommend that you look down in my video description below. I'm going to give you a link to a chart. You can print that off, laminate it, stick it on the side of your welder, and that way you got a good starting point. Now, another trick that I have been using for a long time is I take the electrode, I measure the metal part, the diameter of it, not over the flux, and then this is a 1/8 inch diameter, and I turn that into a decimal form. So 1 divided by 8 is 0.125. Then you get rid of the decimal, and that leaves you with 125 amps. Now, that's always kind of been the higher scale of where you'd want this machine to be, and most of them have to be turned down a little bit from there. However, it really does depend on the electrode itself as well as the machine. I find that the newer machines tend to need a little bit less amperage than that, and my older 40, 50, 60-year-old stick welding machines, they like to have that higher amperage rating. So for example, on this machine, I'm probably going to be around 80 or 90 amps, whereas the other ones behind me, I'd probably be setting it to that full 125 amps. Now, once you try these settings on a piece of scrap metal before you start, if you find that your electrode is sticking constantly to the metal and it's really hard to not do that, that's usually because your amperage is too low. So try turning it up a little bit and then trying again. And the other way, if it's too hot, you're going to find that you're blowing through your material, or instead of getting a nice kind of crowned weld bead, you're actually getting it flat or even concave and melting through. That's your amperage too high. Now, on some of these older machines, they're going to have a high range and a low range for setting the amperage, and you have to physically change where your electrode goes into, whether it's low or high. So for example, if I wanted 125 amps, I got to be in the high range, so it's going to go here for the electrode, and then you got a crank, and this one has got a red bar, and you just have to spin it until you get to your 125 amps. Now, as for what type of electrode you should be starting out with, I'm going to be making some recommendations for you today. However, keep an eye out for a full video just on electrodes so that you can learn how to decipher what the numbers mean, what the different flux coatings do for you, how to set the polarities, and even the different kind of welding positions you can weld on with these electrodes. So keep an eye out for that. Now, for today's recommendations, I would recommend E6013. That's a really good electrode. It has really nice slag peel that comes off, and it should make a really nice, pretty weld for you. Some other commonly used ones in industry are E6010, E6011, E7018. That really makes nice welds. And all of those are going to be able to be set on different polarities so that you can try them all out and see how that works out. Now, once you've got your electrode figured out, you basically have two types of electrode holders. You've got the clamp style here, and then you've got the spin-on style. So let me show you how to put them in. Okay, the clamp-on type is pretty easy. You just got a little handle here, and you depress it and opens the jaws. Go ahead and stick your electrode on with the metal part. Let go of the handle, and there you go. The spin-on type basically has a handle that's movable, and when you spin it counterclockwise, it opens up the jaws in the end. When you spin it clockwise, that tightens the jaws onto the end of your electrode. So open it up first, stick your electrode down into the hole, hold the head and tighten the handle clockwise to lock it in place, like that. And another tip, once you've got your electrode in your holder like this, to stop having to put your arms up like this and having it shaky while you're trying to weld, you could just put a little bend on that electrode. Now you can rest your arms and elbows on the table so that you are not shaking so much while you're doing your welding. All right, so the next thing we need to talk about is the angle of the electrode when you're actually welding. Now we have two angles that we are concerned about. The first one is the angle in the direction of travel, and the other one is the working angle from this way. Now, there's an old saying to help you remember what you're supposed to do. If it has slag, you drag. So we are going to have roughly about a 10 to 20 degree angle in the direction of travel so that we are dragging the puddle behind us. Now what that's going to do is it's going to focus more heat into the part, we're going to get more penetration, and it also helps prevent sucking in the slag and the flux into our weld bead, which is going to cause porosity. Now, when we are talking about working angle, which is this way, you're pretty much always going to be 0 degrees, but depending on your project, and if one piece is thicker than the other, or fillets, or maybe you're doing vertical work, you're going to have to change the angles slightly. But for most applications, it's going to be a 10 to 20 degree drag angle with a 0 degree working angle. Okay, the next thing we need to talk about is how do you actually strike an arc? How do you start the welding to start happening? Now, typically what most people will do is they will pinpoint where they want to start, and they'll go down like this, and as soon as they touch the metal, it will stick. And you might hear the machine kind of going, "Arr!" and it's stuck. You can't take it off, and you literally have to pull as you're bending this electrode back and forth to get it to come off. And if you don't do that fast enough, this whole thing heats up red hot, all the flux falls off, and you're gonna have to knock it off or grind it off. Welding gods, why have you forsaken me? This is going to be the most challenging thing as a novice welder learning how to do this for stick welding. So what I recommend is you get a scrap piece of plate steel, and you are going to do a ton of these starts and stops until you get this kind of practice nailed down. Now, what you're going to do instead of just putting it straight down is you are going to try to strike it like you're striking a match. So you kind of pinpoint where you want to go, and then you kind of touch the material as you are moving, and that will initiate the arc and get it kind of stable. And then you very quickly go back to where you wanted to start, and you begin putting down your puddle and beginning your weld bead. Now, when you are doing the striking process, you're going to have these arc burn marks on your project. So if you don't want to see those, what you do is you kind of do the striking where you're going to lay the weld bead. so that when you go back and start welding, you're going to cover up those and you won't see those arcs anymore. Now, some common problems that happen, if you keep sticking it and it just keeps sticking, no matter what you do, you think you're scraping hard enough and fast enough, it might be that your settings are too low, so maybe turn up your amperage 5 or 10 amps and give it another trot. The other thing that can happen is on the end of your electrode. On some electrodes, they really like to burn back a bit, meaning that the metal inside the electrode will burn a couple millimeters past the end where the flux is. And so the next time you go to scrape and start your arc, it just can't do it. It's too much of a gap there to the metal. So there's a couple solutions. Often people just kind of smash the end until it chips off and then it starts. Or you can get a pair of pliers that you kind of just nip the end off. You can get a file and just really quickly kind of take the flux down a little bit. All of those methods work. It's just to try to get that steel down a little bit more so you can initiate the spark. So let's give it a couple strikes and starts. And like I said, get a scrap piece of steel and do strike, get it started, weld for a second or two, and then stop it on purpose. Move to the next spot, strike it, start it. Just do a whole bunch of those until this feels really natural and comfortable. Okay, quick strike, go right back to the beginning, and then we're trying to hold about a 1/8 inch gap. And stop. Drag. Go back to the start, get a puddle, stop. Drag, go back to the beginning, get a puddle, stop. You just keep doing this until it feels super comfortable. Drag, back to the start, stop. Okay, once you feel comfortable with that, then you're ready to start doing an actual weld bead. If I haven't mentioned already, I am running E6013 electrode. I've got it on DC electrode positive, and I'm running 90 amps. So let's give a little strike start here, and I'll talk as I'm welding. Okay, strike start. Lay it there for a second to get some heat in, and then start moving. Now, I don't like to just drag in a line. I like to make a C movement, and I try to keep the C's, the distance between my C's even. And the top and bottom of the C's need to be the same as well. And all while you are trying to constantly feed that electrode down to maintain about 1/8 of an inch gap. Now, you got to try to keep an eye on where you're going so you got a nice straight bead. And when you get near the end, you want to pause for a second, get some heat in there so you don't have a crater, and don't pull up and away off on your project. Pull it up over your flux. That way you can hide your arc burn lines. And whatever you do, do not chip the slag off when it is glowing red hot. You are going to want to wait till that heats out. Otherwise, what happens is that flux tends to mush up rather than come off. Now, the thing that I love about stick welding is that realistically, when you run your bead and you look at it, it looks like garbage. It looks like a piece of poop sitting there. However, you take your chipping hammer, and the best thing about this is it's like Christmas. You just pop that top off, the slag pops off like a turtle shell, and you have this beautiful looking weld underneath that you can be proud of. So like I said, let it cool down a bit, and you will be able to know roughly what your weld's like when you start chipping the slag off. If it tends to not want to come off and it sticks a lot and chunks are coming off but not all in one piece, you might have it set too cold and there's some undercuts where the slag is kind of sitting in and grabbing a hold of, or you might have some holes or some porosity going on. But if it's a nice weld bead, smooth, no undercuts, it should just come off. Now you don't want to smash the crap out of this. You can sometimes even just drag this along the side, but some light kind of taps. And depending on the electrode, you will have this pretty thing underneath. Now don't forget that every time you stop and start, you are going to have to use the chipping hammer and wire brush it clean so that you don't trap any of this stuff in the next weld bead. All right, let's take a closer look at this and see how I did. So take a look at this weld bead right at the beginning. You don't see a crater where I just started moving and welding. I paused for a sec, got some heat in there and some material before I started. There is no holes or porosity in the weld bead, so that's good. The distinct C pattern on the weld bead is there, and the distance between those C's is nice and even. So as I was making the C's, the distance between them is the same. I also have the top and the bottom of the C's as the same, so this doesn't go skinnier or wider. Now, it does go a touch wider at the end, but you can also see that it's because of heat. So you have to remember that we didn't preheat this piece. So as you are dumping heat into the material, it's going to start acting like it's a hotter weld bead because the material itself is getting hotter as well. Now, there isn't a lot of spatter on here, so I must have been able to maintain that 1/8 of an inch gap as I went along by constantly feeding the electrode in as I was moving. And then as for heat and penetration, the weld bead isn't sitting up high and looking like a worm or bird poop on top, so it doesn't have any undercuts. So it was hot enough, yet not so hot that it was actually flat and a super wide weld bead and maybe even concave as it started to sink through this. So overall, not a bad weld. And at the end, there isn't a huge crater where I just pulled off and didn't have enough material. So I paused for a sec, got some heat, put some material in. And there is no arc burn lines because when I pulled it away, I went up over my previous weld where the slag is. So not my greatest weld, but not bad for today's lesson here. There's a wrap in another video from Way of the Wrench. This time it's on an introduction into stick welding. Hopefully I was able to impart some of my experience and knowledge onto you new and upcoming welders out there. And that way you feel comfortable enough to start on your own and start getting some of your own experience going. Look forward to some more stick welding videos coming out soon. I'm going to be planning on making one for diagnosing your stick welds so you can figure out what's going on there. I'm going to do one on electrodes so that you can figure out how to decipher those numbers and the flux codings and some tricks there. I'm probably going to do one on how to do fillet welds for stick welding because there's some really neat info there as well. And as always, we're going to start thinking of a stick welding project video for you guys. Something thick plate steel. Maybe we should make a tank. You want me to make a tank? Put it down in the comment section below. Or if you got your own ideas for stick welding projects, put them down there for me. And as always, if you haven't followed us on Instagram yet, why don't you do that so that you can find out what's going on in the shop in between videos. Until next time, take it easy.